This conference will now be recorded.
Yeah, can you hear me?
Yes, now I can hear you, Shiva.
Okay. So today our activity is to understand AKS, AKS creation. And the second one is to create AKS cluster manually. Then to create it or to automate it. To automate AKS cluster creation. So generally what is AKS actually? AKS stands for Azure Kubernetes Services. Kubernetes services. Kubernetes service. Now, before you understand what exactly AKS and what is Kubernetes, and let us understand, okay, containers. So generally, when I want to run one application, so there are different ways of running a application. Let me open one diagram. So generally, when you want to run any web application, so there are actually three different approaches. Three different approaches are available. So in first generation, in first model, okay, suppose you wanted to run one web application. So to run a web application, just imagine that I have purchased, I am using a physical system with i7 processor, 5 TB storage, 64 GB of RAM. Okay, and this is assume that this is one e-commerce application like Amazon shopping website, Flipkart, or it can be any online food delivery application. Okay, and it can be Book My Show, anything. This is this system is for assume that the production and uh, present configuration is i7 5 TB 64 GB of RAM. This is very high configured system, but unfortunately what is happening here, okay, and I am not using these many system resources, just I am using only 1 TB of storage, 16 GB of memory. All my system resources are wasted because we have a system with 5 TB storage, 64 GB of RAM memory, but presently we are using only 1 TB 16 GB of memory. That is high. Okay, that is this system resources I am using in peak hours. In non-peak hours, we are not using even this much capacity, this much resources. So in this case, what is happening here? All my system resources are wasted. Okay, so to overcome this problem, okay, in generation 2, what people has done means they have purchased a physical machine, okay, and they have they have set up one operating system called Windows. Okay, this can be a physical system or virtual machine, whatever it may be. But here in the same scenario, so here we have 64 GB of RAM, but we are using 16 GB only. So the leftover memory is 48 GB. And when it comes to actual storage is 5 TB, but we are using only 1 TB. Here 4 TB is leftover. But I don't want to waste these resources. So to reuse these resources, on the top of this physical server, I can have one hypervisor software. So hypervisor softwares are like Oracle VirtualBox, Hyper-V, VMware, okay, and many other hypervisor softwares are there. Using hypervisor software, I can create virtual machines on the top of hypervisor. Okay, hypervisor is a software which is going to allow you to create virtual machines, VM1, VM2, VM3. And VM1, VM2, VM3 will be acting as physical servers. And assume that for first virtual machine I have allocated 4 GB, second virtual machine also have allocated 4 GB of storage, and third virtual machine also have allocated 4 GB of storage, and every virtual machine, okay, is utilizing 4 GB of memory, 4 GB, 4 GB, 4 GB. So here leftover memory is 48 is leftover here, but here still there is some memory, okay, to use. This is that means in the generation 2, what is happening here? In generation 2, all my system resources are wasted. To overcome this problem, on the top of my host operating system, I installed hypervisor. On the top of hypervisor, okay, I'm using different virtual machines with different operating systems. So every virtual machine will be acting as a separate physical server. Every virtual machine will be having its own memory, its own storage, its own IP address. Everything is individual. But in this case, what is happening here? So generation 1 approach is better when compared to generation 1. But if you consider one more scenario, there is one more scenario here. Here, suppose, imagine that this is your virtual machine, and in this virtual machine, you are running one application like e-commerce application. All we know that e-commerce application is the combination of many modules like login module, net banking, authentication, delivery. And all we know that here in the month of November or December, Flipkart, Amazon will be giving some offers. Okay, on the occasion of Christmas, New Year festival, and Thanksgiving Day. Okay, these are the occasions where people will get discounts. And in the discount time, definitely this virtual machine is heavily used. One virtual machine is not enough for responding to number of users. Okay, but here, so in order to respond to more number of users, I need to replicate one more virtual machine. One more virtual machine, one virtual machine. Suppose every virtual machine can handle 500 users, and there are suppose 2000 users are connected. For 2000 users, one virtual machine is not enough. Definitely we need to have 4 virtual machines. Just this is only rough calculation. Okay, and every time when I replicate a virtual machine, what is happening here? A new operating system is replicated, and my e-commerce application will also be replicated in every new virtual machine. But imagine, okay, suppose your e-commerce application size is only 100 MB. This is application size, but every operating system takes more than 1000 MB. This is minimum size, more than 1000 MB. Just for the sake of 100 MB of e-commerce application, is it a correct idea to allocate 1000 MB of storage for operating system? It is not correct, right? Because my application size is 100 MB only. For the sake of 100 MB, is it correct idea to allocate 1000 MB for OS? It is not correct. It is not a good idea. It is not a correct approach. Okay. And for this, to overcome this kind of virtual machine scenario, we are going to have something like containers. We are going to have something like containers. So what is a container actually? Container is like a virtual machine, but it is not a virtual machine. Okay, which can be created with a lightweight operating system. Lightweight operating system. Even with 5 MB of storage also, you can create a container. Okay, even with 5 MB of storage also, you can create a container. Even 7 MB storage. Okay, where 1000 MB, where 5 MB. There is a lot of difference, right? So the advantage of containers is it does not take complete operating system like virtual machine is taking a operating system with 1000 MB of space. A container will be created with a lightweight operating system, okay, and that is large enough to run your application. That is large enough to run your application. To run my application, I need only minimal operating system. I don't require any full-fledged complete operating system. I don't have control. I don't have any control over the operating system. Okay, it is very thin operating system. It is very light operating system. Now to create containers, definitely I need, okay, images. So who is going to provide images here? There are companies. Okay, there is a popular company called Docker, hub.docker.com. This is just like an image store. You have to create one account here. So if you want to take images from this, you have to create some account. So yeah, these are the images that are created and by me. Okay, so it contains some lakhs of images. So suppose I want to search for Jenkins image. Jenkins is a CI/CD software. Docker pull Jenkins. When you execute this Docker pull Jenkins command, okay, automatically, Okay. Jenkins image will be downloaded. Okay. Now this is the image that is required to create a container. From the image you can create a container. Okay. Now, so here if you want to practice containers, I will show one website to you. That is your interest, but it is not our course. It is not part of our course. So there is a Docker playground here. Docker playground. So to work with the Docker playground, this one, you have to have an account here. You have to have an account in hub.docker.com. So I'm signing out. So you can create a account in hub.docker.com. Are you seeing sign up here? Click on sign up and uh, copy your email address, username and password. Within minutes your account will be created. So once your account is created, so if you want to log in into your account, okay, just type your credentials, hub.docker.com. Without having account, even you cannot log in into this account. Or once your account is created, click on sign in. This is my username. Now from here you can download anything. So suppose I want to download Alpine. Alpine is one kind of Linux. Okay. Now once your account is created, you can go and create images here. And are you seeing login here? Docker login. Start. So this is just like a sandbox, guys. Okay. Without installing Docker on your virtual machine or physical machine, you can practice here. Are you seeing add new instance here? Click on add new instance. So you can practice for 4 hours here. Without setting up Docker, you can practice Docker for 4 hours. And suppose I want to download, okay, full Alpine. So this is going to download the image. And once downloading the image, if you want to see Docker image ls, are you seeing one image is showing here? Alpine latest. Okay, 2 weeks ago. Are you seeing how much small size it is? Even we don't have my MP3 file with this size. Okay, can you create a virtual machine with this size? Highly impossible. It is highly impossible. And in the same way, I am going to download one more image like Ubuntu. Now if you execute Docker image ls, okay, 2 images are there. Okay, one is Ubuntu. What did I say? Ubuntu. Okay. Now let us download one more image. This is BusyBox. BusyBox is also one kind of Linux. Now say Docker image ls. It's in 4.26 MB. How much small it is? So here every container will be created like a isolated area in your virtual machine. Every container will get its own IP address, its own memory, its own storage, its own tree, process tree, okay, its own volume, its own storage. Everything will be created when you say Docker container run. Okay, so from the image, if you want to create a container, Docker container, this is a command here. Docker container run hyphen name C1, run it in IT mode, and the container to be created is C1. And what is the image? From this image you want to create a container. So this is a command to create a container. Now we are inside the container. Here this is the file system of your container. Every container can be thought like a isolated area. So these isolations are created internally by using namespaces concept of Linux. Okay, so this is about container, and container concept you can use in dev environment and test environment. And when you are working as a DevOps engineer or cloud engineer, definitely, okay, you need to manage totally 5 to 6 projects. 3 or 4 projects will be running on virtual machines. Definitely 3 or 4 projects will be running on containers. Okay, so like container creation, container deletion, container stopping, okay, running a application inside a container, that is your responsibility. So in case of 1 or 2 containers, you can use Docker. But in production, okay, containers will not be giving features like auto scaling, load balancing, okay, automatic failovers, self-healing. Okay, these features are not covered by containers. And to maintain all these features in production environment, definitely we are going to use, okay, softwares like orchestration softwares. Orchestration softwares. So orchestration softwares are going to provide, okay, orchestration softwares are going to manage containers first, and they are going to distribute the load across containers. Okay, self-healing, load balancing, and service discovery, and high availability, and maintaining latest versions, okay, new updates. So that kind of features are available in orchestration tool. So but what are the orchestration softwares here? When it comes to Docker, there is a orchestration software called Docker Swarm and Kubernetes. So here Kubernetes. Okay, so Kubernetes is a software Kubernetes provides to overcome the limitations of containers or Docker containers. Docker containers, K8s like orchestration softwares provides the following features. Okay, so automatic self-healing. Self-healing means what? If suppose my requirement is I wanted to take 5 containers or 5 pods. Pod is a smallest unit that can be created in Kubernetes, and you are specifying that 3 pods must be created. That is called a desired state. So in case of some system failure, what happens here? One pod might be killed, and the system must detect it, and it must the deleted pod must be recreated. In the place of deleted one, a new pod must be created. That is nothing but self-healing. And automatic updates. Automatic updates means suppose in the pods, okay, in Kubernetes the smallest unit is pod. In Docker the smallest unit is container. Pod contains containers. Pod contains containers, right? Now, so if one of the suppose pod is running some application, and that application is suppose outdated, a latest version has come, and without stopping old version, okay, so old version as well a new version must be running. So if old version is down, people from internet will be suffering a lot because they are not able to access the application. So without stopping old version, okay, automatically, okay, orchestration software must be able to take the old version to latest version. That is automatic updates. And load balancing. service discovery. And storage orchestration. Yeah, these are the major features that must be supported by orchestration softwares like Kubernetes. Okay. Now, when it comes to Kubernetes setup and when it comes to dev and QA environments, so we can set up Kubernetes, okay, in a manual way, okay. So like how you install C, C++, Java softwares on virtual machines, okay, there is a documentation given to you, okay, according to documentation, okay, you have to follow all the steps, okay. Suppose here there is a site here, so here Kubernetes community has given a kube ADM installation. This is manual installation, guys. You have to simply follow, you have to this documentation, and here 1.28. So here you need to run all these commands here. This is manual installation. This process of installing Kubernetes on your virtual machine is called as kube process. This is especially suitable for dev and QA environments. But when it comes to production, okay, so in dev and QA, one more is there, Minikube and Kube Spray. These are the different ways of setting up Kubernetes on your virtual machines manually. But it is a laborious job. No one is going to do that. Okay, because in your companies long back the cluster was set by somebody else. It is not your responsibility, my responsibility. Because this Kubernetes setup for dev and QA environments is this is manual installation. And in every cloud, so Kubernetes or K8s is available as a service. And when it comes to Azure, okay, so there is a service called AKS. AKS stands for Azure Kubernetes Services. Azure Kubernetes Service. Okay, nowadays most of the persons, most of the industries are in production. Okay, this manual installation we don't use in production. So this manual installation, it is suitable for dev and QA environments only. Definitely in every organization, okay, in production environment, okay, this AKS is used 70 to 80%. 70 to 80% industries are using AKS. And when it comes to AWS, there is a service in AWS, EKS. This is Elastic Kubernetes Service. But this is not that much popular because it is expensive and it is not that much easy to set up. And when it comes to AKS, okay, it is very easy to set up. And when it comes to EKS, this is very difficult to set up. And this is also very expensive. It is also very expensive. Okay, and here this is AKS, and when it comes to AKS, that is from AWS. When it comes to GCP, Google Cloud, there is another service. There is another service called GKE. That is Google Kubernetes. Yeah. Okay, so this you know, no need to set up, no need to install anything in cloud platform. Okay, so every cloud offers Kubernetes cluster as a service. Kubernetes is available as a service. Okay, now, so what are the advantages of having Kubernetes on every cloud as a service? So what are the benefits here? When it comes to benefits of AKS service, no manual installation. Okay, upgradation is very simple. Today I am using 1.27 version of Kubernetes. Tomorrow in the morning, okay, latest version has come. Within minutes, you can upgrade your cluster from old version to latest version. But whereas in manual installation, this is very difficult task. Okay, upgradation is very simple. And when it comes AKS, we have AKS in Azure. AKS in Azure, we have two ways of setup. In cloud also we have two ways of setup. From website you can create a AKS cluster. From Terraform also you can create it, which is a automated way. So your responsibility as a cloud admin, cloud automation engineer is to set up the cluster and not to use the cluster. You have to manage the cluster. And DevOps engineers will be writing manifest, okay, to create objects and to create deployments, services, load balancers. They are going to create in the form of manifest. Your responsibility and my responsibility as a cloud automation engineer is, okay, to automate AKS cluster creation process. So before you are going to create AKS from Terraform, first let us see how to create it from portal website. Okay, is it clear, guys, so far?
Yes, Shiva.
So two ways of setup. One is from portal. This is nothing but website. And automation, automated way. Automation means from Terraform we are going to create it. Right. Now let us go to AKS cluster. Let us go to Azure portal first. It's asking every time here. Okay, this is our Azure homepage, landing page. Here in the left side blade, if you don't find AKS, in the search box, you directly type AKS. This is Kubernetes services and create it. Kubernetes cluster. I don't have any resource group. So let us create one resource group. Kube.org. Cluster name is my cluster. And availability zone, it can be exactly like this. So it is asking whether you want to create cluster for dev test or production standard, production economy, production enterprise. I am selecting dev test, or you can select production standard. The next page, what it is asking. The agent pool, node size, how many nodes you wanted to create. I want to create it only 2 nodes. Maximum it can up to 5 nodes. Because Kubernetes cluster means generally we are going to have 2 components. Okay, let me show the architecture also. It is very simple. The architecture of Kubernetes I will show. The online folder, I have Kubernetes. Here this is a high level architecture of Kubernetes here, Kubernetes cluster. So in any Kubernetes cluster, basically there are 2 components are available. One is manager node. Okay, so which is completely, it will take care of nodes. Actual application load will be running on node 1, node 2, node 3. You can have as many nodes as you want. And manager node, just it does not do any activity, just it is going to take care of. Okay, so it is a manager to all the nodes. And every manager node, okay, will have 4 components: Kube API server, cluster store, Kube scheduler, Kube controller manager. And every node will contain 3 components: kubelet, kube proxy, container runtime. And every node contains 3 components, and manager node contains 4 components. Totally, when it comes to Kubernetes, there are 8 components. 4 plus 3 plus 1 more component is there here. This is kube controller manager. Especially this component is available when you are using Kubernetes on cluster on cloud. And in manual installation, this part kube controller manager will not be there. Cloud controller manager, sorry. Cloud controller manager will not be there on manual cluster. And what are the responsibilities of each and every node here? And generally, when it comes to Kubernetes, we are going to create objects. Objects can be created either in the form of YAML files or REST API. And to create objects, we are going to use some format called YAML. Okay, so here in YAML file, we are going to describe what kind of object you wanted to create. Okay, and how many objects you wanted to create. Okay, so that kind of information we are going to mention in YAML file. And this input is taken by Kube API server. Kube API server. And cluster store is going to store all the pods. Okay, so how many pods are running? So here in Kubernetes, I told you, right, the smallest unit is pod. In Docker, the smallest unit is container. Okay, here pod will contain containers. And Kube API server is going to take request from YAML file. And the actual information is stored in cluster store. This is just like a database for your cluster. And what is the scheduler? Scheduler is going to create pods. Scheduler is going to schedule pods across the nodes. It is going to know, okay, what nodes are free, in what on what node pods can be allocated, pods can be scheduled. The scheduling duty is done by Kube scheduler. And Kube controller manager is going to maintain the desired state. Desired state means, suppose I wanted to run 10 pods. It is going to see always whether 10 pods are running or not. So if one pod is crashed, immediately that is reported to Kube scheduler. And Kube scheduler is go recreate one more new pod to maintain desired state. And these are the 4 components that are running in on manager node. And when it comes to node 1, node 2, node 3, so every node will contain 3 components: kubelet, kube proxy, container runtime. And kubelet simply it is going to take order from kube API server, master node. It is going to listen to manager node. And kubeproxy, it is a agent which is going to maintain network connectivity between all nodes and master node and nodes, worker nodes. And container runtime is responsible for starting containers, stopping containers, downloading images. That kind of responsibility is there with the container runtime. Okay, so combination of manager node and worker nodes is called as a Kubernetes cluster, AKS cluster. And here, so here you can have one or more managers, but definitely we must have more than one node, more than one worker node. Here you can specify how many nodes you wanted to create. Minimum is 2, maximum is 5, and I don't want to disturb this. Update. And in the next page it is going to ask which Kubernetes version you wanted to do. Are you seeing at Kubernetes version also? Default is 1.27.7. Next. So I don't want to touch other details, and it will create a AKS cluster within 5 minutes. But when it comes to manual installation, it takes more than 1 hour. Sometimes if the network connectivity is poor, so it might take more than 1 hour also. That depends on number of nodes, how many you are configuring. So if number of nodes are more, okay, so the installation process becomes very slow and it takes more time. And let us create this cluster. So here if you want to automate this process, the Terraform script will be like this. Terraform Azure AKS creation. Now this is a script. First he is creating a resource group. Within this resource group, he is going to create a AKS cluster. Now the resource type is Azure RM Kubernetes cluster. Cluster name for future reference, further reference is example. This is the name of the cluster. Location is resource group location. Name is this resource group. And default pool. This is a node count. How many nodes you wanted to create in the cluster? Identity, tags, output. Okay, once your cluster is created, okay, the cluster name, the client certificate will be output kube config. This is all about cluster creation from Terraform. Identity. Okay, my cluster is created here. See. And here if you want to create connect to cluster from kubectl is a command line to speak with Kubernetes cluster. And if you have to execute this command to connect to cluster, and to connect to cluster, we are going to use kubectl. So kubectl can be used from Cloud Shell. Cloud Shell already I told you, right? So if you want to open Cloud Shell window, here this shell.azure.com. Just run this command. This is connecting to cluster. And here you can use kubectl command line to speak with Kubernetes cluster. Kubectl get nodes. It is going to give information about all nodes. So internally, it has taken okay Ubuntu image. Nodes are with two nodes are created here. Two nodes, every node is using Ubuntu operating system. See, so this is how you can create a cluster in a manual way. And who is going to use? So again, if you are a DevOps engineer, you have to write manifest. Manifest file to create objects like pods, replica sets, replication controllers, service object, load balancer, jobs, configuration, config maps and secrets. Okay, and volumes. Okay, so if you are also a DevOps engineer, you will be writing manifest files. Okay, so this is how you can create a cluster in a manual way. Now let us delete this cluster. I will show how you can automate this process. Go to resource groups. Kubernetes is a resource group name. Delete it. Okay. Now let us create it from Terraform. So to create a Terraform, first to create one local directory. In the D drive, I am creating a folder. Terraform Azure AKS 28 December Microsoft. And let us create provider file. So how to write provider? Terraform Azure provider. Say Terraform init. Okay, it is done. And connected to AWS account. Sorry, Azure account. AJ login. This is my account. Okay, it is done successfully. Now let us write Terraform script for creating AKS cluster. Now I am writing aks.tf. Let us exactly take this. So these output sections can be omitted. Okay, so I will show what is the importance of output section. And first let us validate Terraform validate. Now say Terraform. First let me see whether manual RG is deleted or not. Now let us wait for 2 minutes. Let it be deleted because sometimes what happens here, clusters may clash. Now let us run this Terraform apply auto approve. Let us node count equal to 1 only, right? and my cluster is created. So here, where to see the cluster here? So here, if you refresh this, AKS clusters. Are you seeing example AKS 1.27, West Europe, pay as you go.
Yes, Shiva.
Yeah, this is how you can create a cluster from
Okay.
Terraform. I hope you understood everything, whatever we have discussed today. And watch this video once again, because this is a very important automation part. Okay, as a cloud automation engineer, you have to do this task.
Okay, so all these are our responsibility, right?
Yes.
Okay, got it. Okay.
Okay, so today I'm stopping. Tomorrow we meet again at the same time. And before that, I'm destroying this.
Okay. Great.
Because it is very expensive.
Oh, okay.
Okay, Mahendra, we can stop the session. It will be deleted.
Sure, Shiva. Thank you.
Thank you. Thank you.